For this next problem, we'll be working problem 8 from chapter 3 that says we'll be calculating the KEQ from the delta G naught prime. Write the equilibrium constant KEQ for the hydrolysis of creatine phosphate and calculate a value for KEQ at 25 degrees C from the value of delta G naught in table 3.2. So I looked up table 3.2 from the book and I found this table. So creatine phosphate goes to creatine plus inorganic phosphate in a hydrolysis reaction with a delta G naught prime of negative 43.3 kilojoules per mole. Okay, so from that piece of information we can calculate the KEQ. So we had this equation, and I think I went over this in an earlier video. Okay, let's just start from the beginning. So this is problem 8. We need to calculate KEQ from delta G naught prime, and for this reaction, the hydrolysis of creatine phosphate, our delta G naught prime is negative 43.3 kilojoules per mole, okay, at the temperature we're at, 25 degrees C. Okay, so we could write that reaction down. Creatine phosphate plus water yields creatine plus inorganic phosphate, and again that delta G naught prime is negative 43.3 kilojoules per mole. Alright, so we can write a KEQ for this reaction. That's what we're asked to do. First is equal to the concentration of products over reactants, so that's creatine at equilibrium times inorganic phosphate at equilibrium. The water doesn't count, so we've got creatine phosphate at equilibrium. Okay, so remember this equation. Delta G naught prime is equal to negative RT ln of KEQ. So we can solve for KEQ, which is equal to e to the negative delta G naught prime divided by RT. So this is getting KEQ from delta G naught prime. And so in this case, that's going to be e to the negative 43.3, and we need that in joules because we're going to use the gas law constant in joules, times 10 to the third, so just multiply that times 1,000. That looks absolutely terrible. Divided by 8.314 joules per mole Kelvin times 298. Okay, and so that KEQ is equal to 3.89 times 10 to the 7th in this case.